Welcome to another show. In this episode, we'll be talking about jointing methods for copper and plastic pipes, the pros and the cons. So first of all, here's my friend Sean to tell you a bit more about the podcast. Thank you for listening to another Gaslec podcast, the show to help DIYers, new people into the industry, and those who are wanting to expand their knowledge. Each week we'll pick a topic and go into details. And with special guests and listeners' questions answered, we will look forward to some of the conversations. So let's get back to the show. Right, so the most popular jointing methods, as most people will know, will be called soldering. So on copper pipe, we heat it up to a couple of 100 degrees, and then we put some flux on clean the pipe up, clean the fittings up. Put some flux on, heat it, and then put some solder on, and that's called soldering, or some people call it sweating. So when you get so hot, you start to sweat and it starts to run. So that's the sort of the nickname for soldering. So that's like the most common, and we've seen all of that. And back a few years ago, copper pipe changed a lot. So with the price of copper going up, we've now got a lot of other material that's inside copper, inside the tube itself. So it's a lot thinner, it's a lot softer than what it used to be. So there was a jointing method called swaging, which was basically stretching the copper pipe, 15 and 22 commonly. Instead of putting a coupling in line, you get a piece of copper, and then you put like a flaring device in, and you hit it, and then it stretches the pipe out. So that was called swaging. Don't really see that too much, because I've personally had it myself where you start to split the pipe, where it's just too thin and just too cheap these days and too soft. It was never authorised on gas, only on water only, where you had the two copper pipes soldering across to each other, which was great, but it was the very first bit where there isn't none, but the pipe is stretched. And it's a lot thinner than what the design of it was. So never authorised on gas, as far as I'm aware. So the another type is like the plastic pipe. So we've all seen sort of white plastic pipe and the plastic fittings, and we call them push fittings. Typically, you just push them in. So there's a couple of types. You've got the demountable, sort of the John Geese stuff, where you put them in and you've got the screw and you can demount them by pulling the little collar back with your fingers quite easily. Then you've got like the HEP 2.0 stuff, which is similar idea, different manufacturer. And in that, you have to use like a tool to push them in and then pull them apart. And then the other type is like a grey type. It's got like a tooth ring. I'm not quite sure what you call it, but it's a bit of a one-way venture. You sort of push them in, done, and it self grips. And it's really difficult to take apart, and I don't think they actually will guarantee, if you did manage to get them apart, to reuse the joint. So it's not really a reusable joint. Typically they're dark grey. I think I've seen them a few in white or an off-white colour. So yeah, that's on the plastic side. So a few manufacturers have come up with their versions of that. Good thing about the plastic pipes is you can get them up to a 250 metre coil, 100 metre coil, 50 metre, 25. They do a 15 and a 10. So you can have a long run of water pipe, which is all okay because it's all potable water approved, RAS approved. So you can run that for 10 metres without a single joint in it. If you're running from one end to a loft to the other, you could then run it all the way through without any joints in it, without any worry of sort of leaks forming and weak points of joints and junctions. So you don't need any heat with it as well. You don't use a blow lamp. So you've got the heat consideration. Sometimes you have to get hot work permits. If you're working in sort of schools, hospitals, commercial environments, obviously you've got smoke detectors, smoke alarms. So, all that stuff is then activated with heat. So we try and use in commercial aspects heat as least as possible, really. And if you're using heat on gas, the heat in the gas pipe, obviously as it's starting to cool down, the air inside the pipe as it's cooling is contracting, and as it contracts, it makes it look like on the water gauge that you've got a gas drop, and you haven't. It's the pipe cooling, so you've got a bit of a period of time you've got to allow the pipe to cool down before you could do a gas test on it. Obviously, we don't use gas on plastic pipe anyway, or not that sort of plastic pipe. But yeah, so that's on the plastic. So there's a place for everything, from the copper pipe to the plastic pipe. But yeah, so anyway, we'll talk about jointing methods. So then we're going over to sort of compression fittings. So these are your typical sort of DIY stuff when you see it in the with a bit of DIY plumbing. You just push the pipes in, whether it's copper or plastic, doesn't matter, and then you push them in. You've got the olive and the nut, and you offer them up, and then you tighten them up with a pair of grips and a spanner. They're also called demountable joints because they can come apart easily, sometimes through vibration and moving around, or just by two spanners. So yeah, a lot of DIYers use that because you don't really need anything technical tool-wise to get those sort of jobs done. What we see all the time when you see DIYers, they start using white PTFE tape up the thread of the fitting, so you see the nut and you see a little bit of white PTFE tape. So how we do compression joints is that we offer it up, no PTFE tape in sight, and just a little tiny bit of plumber's paste just on the olive, and that just helps the nut pull against the fitting and takes the friction out of obviously you've got two different types of materials, typically your brass and copper. So as they're just pulling up and they're making a watertight seal, it just takes away that friction just to allow that to pull together. One thing you've got to be careful of is you don't over tighten them. So if you are a little bit heavy handed, I'd say slide your hands up the spanner a bit more so you're a bit closer to the head, so you haven't got too much leverage on it. So, but they don't need to be massively tight. Certainly on the smaller stuff when you're 15. Going up to your 28, you have to start swinging on it a bit more, 35 and 42 and stuff. But certainly on your 15, you ain't got to swing on it. And then sort of press fit as a jointing method. So it's coming a bit more. They're a bit bulbous, but they're not demountable. So you have say for a coupling, for example, and it's got two rubber rings in it. So you offer it up and you have a special tool, and it's basically like a crimper, quite expensive. And then you offer it up, push the button, and it's a battery-operated device, and it goes through a sequence, and it'll squeeze it on, and then you release the jaws, and it's done. So they do them in gas and they do them in water, normally identified by like a yellow gasket ring inside rather than a black gasket ring. Sometimes they're printed on the outside with gas, but from the outside they look copper. They are copper. As a fitting, they say they're a bit bulbous, a bit like the old Yorkshire solder rings where you got that little ring on them. But yeah, in commercial, you're seeing them more and more these days. We've actually got some for some domestic stuff because it is quick. You can have a little bit of water in the pipe and it's not going to be affected by sort of soldering and the heat being taken away by the solder. So from that side, it can leave a few sharp edges. I got caught the other day and I got to cut my finger. So squeezing, we call it squeezing. Yeah, so we call it squeezing, but ultimately it's just a press fit fitting. There's no heat involved. It's quick. You can actually use it with running water and pinch it off. And to date, touching wood, we've had no failures at all on them. So very, very good. The only thing is they're not demountable, and you've got to, with the device being so big, you've got to sort of plan where you put your joints, because that if it's buried down by the side of an expansion or something in a behind some pipe work, you ain't going to get the tool in there. So sometimes you have to think and pull it out of situ, do a couple of presses, get the shape of it, and then drop it into situ and then joint it up from there. So it takes a little bit more thinking. All the fittings are not reusable at all. They're not demountable. They're not reusable. So once you do them, and they're done. And the price of those is comparable, really, to a compression fitting, roughly. So if you was going to use 10 compressions, we'd rather use 10 press fits, to be honest, and then go from there. The only conversation that's going on at the moment is, can you use them on gas in areas where you can't get access to them? So on gas, you can only solder the joints. Certainly, so it's under the floorboard of your house. That's all soldered. You can't use compression fittings where you can't get to them. You can use compression outside, under the boiler, places where you can inspect them and get to them. But anything that's inaccessible, it's got to be a non-demountable joint. So there's conversations going on whether a gas press fitting is considered to be a non-demountable joint. So by the very nature of it, it's not take apartable. You can't. Once you press it, you pressed it. That's it. You play tug of war with it. It's a very secure fitting. So hopefully at the installer show we can, which is coming up in June, be able to meet some of the manufacturers and sort of get a definitive answer on that. But at the moment, not too sure. So there's a few discussions within sort of the other people that we know within the industry about the idea of demountable. So in short, we've got a solder, we've got plastic push fit, we've got compression, and we've got press fit. So that's your main sort of four jointing methods for pipe work. And us personally, if we're doing a new heating system installation, anywhere where we run in, where it can't be seen, we'll run plastic. So underfloors and in lofts, we'll run plastic pipe. And then anywhere where it can be seen, so if we've got any drops in the corner for radiators or radiator legs, we'll run it all in copper. So it does have a place. Plastic has been around for probably about 25 years now, so it has got better and better and better with technology. I've personally had a plastic fitting up to 50 bar of static air pressure, trying to see if when it'll go pop. And at 50 bar, it still hadn't gone pop, and that was a short piece of pipe with just a push fit cap end. So they are very, very good. Typically, the biggest problem you have is when you start introducing the wrong inserts and the wrong fittings with the wrong pipe. So all the different manufacturers out there. So personally, we stick to HEP. We stick to one product. So all of our pipe, all of our fittings, all of our inserts are all the same manufacturer, which reduces the issues of failure. So we've had a very, very good success rate since introducing. We've had a couple of failures, and typically that's down to we pick the wrong fitting up for the wrong piece of pipe, because it's sometimes not always that obvious. So there we are. So thank you very much for listening. So hopefully it's been a bit of a journey, and you've learned something through the different pipe jointing methods and fixing. If you've got any questions you want answered, any subjects you want covered, and this subject actually come from another plumber, and I was talking to him, a friend of mine, Gareth, and I said to him, do you want to come on the podcast? Have you got any ideas? And he said, what about jointing methods? So there we are. So that's how we do it. Okay, guys, any feedback you want to give us? Podcast@gaslec.net. Take care, guys. Have a great week. Thank you.